starting the recording also. So let's start with a quick sort of recap of the important things that we learned about vectors in the first session. So first of all, we learned what were vectors themselves, okay, versus what were scalars. And that I think is pretty clear to all of you. So in case there is ever confusion about a given quantity, whether it is a vector or a scalar quantity, you can always understand it like we did for the concept of current, electricity versus force. If the addition of two quantities depends their acting, then they are vector quantities. If the addition is done just like a arithmetic addition, like you add two electric currents, just like you would add two scalar quantities, then they become scalar quantities. Okay. Then we saw notation about vectors. So we saw that this symbol, still have some people who are in the waiting room. So yeah, so then we saw the notation for vectors is such that we put an arrow on top of whatever symbol to represent a vector quantity, whereas when we want to represent its modulus or just its magnitude, we put it between two bars. Okay. Or sometimes for the magnitude, we might just use this symbol, which is the same as a scalar, but the proper notation for magnitude of a vector is given by this. Proper notation for a vector itself is given like this. Okay. That's the other thing we saw. Whereas scalar quantities, they are just notated by a symbol without any arrow. So that's simple. Okay. And then we went on to see what we call the geometrical representation of a vector. So we saw that geometrical representation here. Okay. We represent a vector with an arrow. You know, this arrow should not be confused with the arrow for the symbol. The arrow for the symbol is just a small arrow that we use on top of the symbol. Its direction and its length and all that are not significant. But the arrow that we use for this thing, for the geometrical representation, that is a significant quantity. That is, so the arrow actually has a length which becomes proportionate to the magnitude, and it has a direction, or it has an angle along which it is acting. Still have some more people joining in. Yeah. So the vector has, the arrow of the vector, it has a length. Now the length of the arrow is proportional to the magnitude of the vector, whereas the arrow head points along a certain direction. So that direction of the arrowhead actually represents what we call the line of action of the vector. The direction represents the line of action. That means it represents the direction along which that vector is acting. So for example, if it is a force, it is acting along this line of action. If it is a displacement, it is acting along this line. Okay, so that is what we mean by line of action of the vector. Okay. Then based on that, we saw how we can do certain types of vector operations. Still some more people coming in. Just hang on a second. Yes. So we saw how we can do vector operations. So for example, we saw that if we have a vector multiplied by a scalar quantity, like vector b is equal to n times vector e. Okay, then how to deal with that? So for example, we saw that if vector b is, let's say, 0.5 times vector e. So what that means, so now the scalar quantity we are multiplying with the vector e. So on the right hand side, the operation that we got, it's a vector multiplied by a scalar. So this operation is such that the scalar quantity is a positive quantity. So it means that the vector b is parallel to the vector e. Okay, and the value of it, or the scalar quantity's magnitude, is 0.5. So that means that the magnitude of the vector b, mod b, is equal to 0.5 times mod a, or half of mod a. So that would mean something like this, that if vector e is, suppose, a vector which is pointing like this, suppose in this example, vector e is something like this, then alongside it I could draw vector b, which would be like this. It would be, it doesn't matter whether I draw like this, right on top of it or alongside. As long as it's parallel is fine. And as long as the length of this vector should be exactly half. So vector B would be parallel to the first one, and its length would be exactly 0.5 times the first one. So this arrow should be half the length of the arrow which is in blue. So that is what this statement means. So that was the first type of operation we saw. Still some more students joining in. So those who are joining in, we are just so far doing a recap of last time's lectures. So the important points, we are going over them again. So you can just follow. And of course, as I told you, this is a recorded lecture, so you will get the full revision of it if you like, or some part of the revision if you like. Okay. Another example is, suppose we have a vector C, which is, let's say now, minus 1.5 times the vector E. So the fact that there's a minus sign involved, okay, so we are multiplying the quantity E, the vector E, with a scalar quantity which is minus 1.5. So because it is a negative quantity, so what happens? The direction gets reversed. So here C is opposite in direction, or opposite can also be called anti-parallel. That's one and the same thing. So it is opposite or anti-parallel to the vector E. So here if the E was like this, like we drawn earlier, E was a vector like this, then now in this example the vector C should be opposite in direction. So the vector C should be something like this. It should be exactly anti-parallel, and its length should be more because it's 1.5 times. So this would now represent the vector C. Okay. And because this is minus 1.5, so it means that the magnitude of the vector C, now that won't be minus 1.5 because magnitude does not have algebraic sign. So it is simply 1.5 times the magnitude. It just means that the length of this arrow here is 1.5 times the length of this arrow. But because the original scalar quantity that we are multiplying, it is a negative quantity, therefore the direction becomes opposite. Whereas if it was a positive quantity, the direction remains the same. That was the thing, and of course we saw the special case of 0 multiplied by some vector becomes what we call a null vector. Null vector is a vector having 0 magnitude. So this is the third case of this. Okay, now there are some more types of vectors also which you might have heard about, might have read about in somewhere, but we will discuss about them as we come along. But so far, these are the things we have discussed. Then we came to the most important thing of last time lecture, which is to do with what we call the next point was addition of vectors. By what we call the triangle law method. So in this, for example, if I'm just given two vectors, one vector is like this, another vector is like this, vector E and vector B. So I know the magnitude of vector E that is given, the magnitude of vector B that is also given, and the angle theta that is also given, where the angle theta is the angle between the direction of vector E, which is towards the x-axis, you can see, and the vector B, which is at something like this. So this angle over here is theta. So these quantities are given, suppose. I know the values of these, and from that what I want to find is what we call the resultant of the two vectors, or the sum of the two vectors. I want to find this. That means, in other words, I want to find the magnitude of the vector R and the direction of the vector R. Where R is called the resultant. So this term is called the resultant or the sum of the two vectors. Okay. So here, how we calculate the resultant or the sum is just by thinking of the two given vectors as displacements. Okay. So what you do is you understand that the vector E is suppose a displacement, and a vector B is also a displacement, and you want to find out the net displacement when you have actually undergone a displacement of E plus B. That means you have first undergone a displacement of E and then followed that with a displacement which is represented by this arrow. So after net displacement kitna ho raha hai, that is nothing but the resultant sum. So what you do is you imagine that you started from some origin point. Okay, so this is your initial point over here, and from there you made the displacement E. So to understand that displacement A, literally what you do is you pick up that vector E from top and you bring it and you just position it. So this is your starting point. This is where you started from, and this is where you ended up by the time you completed the displacement E. Okay, so if you had stopped at A, this would have been your final position. But now from here you made your second displacement, which was B. So from here your second displacement was like this, which is basically the same arrow that is on top for B. You just pick it up and place it over here. Those arrows are movable. So if you have that vector B over here, all you have to do is pick up this arrow and place it here so that it's starting from here. That's all. Okay. So doing that, you can see that after completing your second displacement of B, this has now become your final position. This is where you ended up. Whereas this was your origin was your initial position where you started from. So as you know from the definition of displacement, what is your net displacement? It is the vector joining the initial with the final position. So this third side of the triangle becomes your resultant. That is why it is called a triangle law, because what we make use of geometrically is that we make use of a triangle whose adjacent sides are the vectors A and B, the two vectors that we are adding. Then the third side automatically becomes the resultant. That is one way to understand the vector triangle. Given the two vectors we have to add A and B, whether they are displacements like we have discussed, or they might even be something else like force or whatever, but we just construct a triangle whose adjacent sides are the vectors A and B. One after the other, the adjacent sides are A and B. So the third side automatically becomes the resultant. So that's what we want to find out. Now, as you can see, the quantities that we know in this triangle are this length here, we know this length is B, and we know this exterior angle here is theta. So from these three informations, what we have to find out is the magnitude of that resultant vector and the direction in which it is lying. So that direction I can denote by this angle. If I can find out this angle and if I can find out the length of this line, then I know the two quantities that I'm looking for. That is the magnitude of the vector R, which is the resultant, and the direction in which it is lying. So to do that, we saw that we apply a bit of trigonometry, as we did last time. That we extend this line, we drop a perpendicular from here, and then we take this as x and this as y. Then you can denote x as b cos theta using trigonometry of this smaller triangle, this right angle triangle. Y as b sine theta. And then in the larger triangle, you can express the hypotenuse r as square root of a plus x ka whole square plus y square. Okay. So doing that, you are able to find out the resultant. Okay. So this was the method that we applied in the last one. Okay, so we'll just go through that. Unfortunately, I'm just having a bit of screen lag over here. So while I resolve the problem with the screen, okay, what I want you people to do is quickly do a revision of so quickly do a revision of this formula that we saw last time. Okay, so just while I'm resolving the problem with the white screen, seems to have gone offline. So just okay. Yeah, so people, I'm just working on my connectivity. So in the meantime, what I'd like you to do is, just keep the worksheet ready with you and go through the first three problems of the worksheet. I'm going to be discussing that next after we complete this formula discussion. Okay, so I think we should be back online with the whiteboard now, and you are able to see this again. So just picking up where we left off. So this was this plus y square. So when we solve this whole thing, we come up with the final formula, which becomes like a ready-made formula which we can use in any problem. So magnitude of E plus B, or magnitude of the resultant vector R, as you can see over here, that becomes, when you replace x and y the way we have written over here, and just expand this, it becomes square root of E square plus B square plus 2ab cos theta. So this is the formula of the triangle geometry. While this is the geometrical construction of the triangle, but this becomes the final formula that we use for finding the third side, which is the unknown, which actually becomes the sum of A and B. And similarly, in that triangle, you can see that tan alpha is nothing but the perpendicular, which is y, upon the base, which is a plus x. So using this formula here, we get the other formula, which is for the angle. Okay. So the angle tan alpha becomes such that its tan is equal to b sine theta upon a plus b cos theta. This becomes this. Okay. So this, for example, is. Okay. So let us look at. So I'm just minimizing this for just a little bit so that you get a quick recollection of this whole thing from last time. Okay. Now we will start with one or two examples of this, and then we will come to the worksheet. So keep the worksheet ready with you to discuss. Okay. All right. So let's see from this, if we want to solve some question like this, how we will solve it. So for example, now we have a problem like this, that the vector E has a magnitude of 3 units, and the vector B has a magnitude of 3 root 2 units, and theta is equal to 45. The angle between E and B. Okay. Just a moment. Let's make this a single unit. Let's make this 1 unit. Okay. So the vector A has a magnitude of 1 unit. The vector B has a magnitude of 3 root 2. Or that 3 root 2 is, as a number, it is approximately equal to 3 into 1.4. So, but anyway, we are writing it as 3 root 2, and the angle between them is 45 degrees. So now we want to find the magnitude of the vector E plus B. Just we want to find the magnitude, how much that is. Okay. So all we have to do here is we have to apply that particular formula which I have written above. So I'm just minimizing so that you can refer to the formula. Now you have to just fit these values into this formula and see what you're getting. So just try this out. Okay, so students who have just entered the meeting again from the waiting room, as I said before, don't worry, it's a recorded lecture, so you will get the full video recorded version of it. So you can refer to it later. So if you can solve this, and yeah, I'm getting some answers. Just a moment, let me verify. Ritika, just be careful. You have to take the square root properly. Okay. Rahil, is it? Rahil Modi, your answer is correct. Good. Somorup, your answer is also correct. Brushant, your answer is correct. Good. So many of you getting this right. Okay. Aman, your answer is correct. Shikhar, your answer is correct. Kushal, you have forgotten to take the square root, but otherwise your answer is correct. Same with Krutika. Same with Ritika. Your answers are correct, but you have to just take the square root properly. Okay. So, the thing is here, you don't have to make the triangle. You have to just use the formula. You can make the triangle if you want, but you can get away by just applying the formula directly. You don't actually need to make the triangle and all that. So what you can do here is you can just do this, that use this formula, that mod of A plus B, the resultant of A plus B has a magnitude, which is square root of A square plus B square plus 2AB cos theta. Now just substitute the values here. So A's magnitude was 1, B's magnitude was 3 root 2, becomes square of this, plus 2 times into mod A into mod B into cos theta. So that's cos 45, which you know is 1 by root 2. Now you know that cos 45 degrees is 1 by root 2, or approximately 0.7 whatever. So next in your calculation, as you can see, this becomes square root of 1 plus 18, okay, because 3 squares are 9 into 2, plus how much does this become? 2 into 1 into 3 root 2 divided by root 2. So the root 2 cancels out and this is plus 6. So as you can see, it becomes square root of 25, which is 5. So 5 units becomes the magnitude of A plus B. Okay, now the unit could be anything depending on what the vectors A and B are. If they are force vectors, then that unit is newtons or dynes. If they are displacement vectors, then that unit is the unit of some displacement, like meter, centimeter, feet, whatever. Okay. But yes, one thing is important, that the two vectors that we are adding, they must be of the same unit. They cannot be of different units. You cannot add newtons with dynes, or for that matter, you cannot add newtons with meters or meters per second or something like that. You can only add quantities which are of the same physical dimension and expressed in the same unit. Okay. Now let's also see how we could have got this by drawing the triangle, though it was not necessary. If I wanted to solve this geometrically, so this would have been like this. That above was by the formula. So geometrically, what I would have to do is, suppose I assume that the vector E is in this direction, because nothing is given, that it's along the x-axis only. So it's just an assumption. So I'm assuming that the vector E is like this, and it has, it's much shorter. So the vector A has a magnitude of only unity. So let's say it's like this. So magnitude 1. Now, comparatively, how is the vector B? So let's understand that. So the vector B is a bit longer. It is 4.2, but also it is at 45 degrees. So it's like this. So vector B is probably something like this. I don't have to draw exactly to scale, but just to understand. So this is the vector V. Now its length is 3 root 2, so approximately 4.2. And this angle over here, if I extend this line, this angle is 45 degrees. Okay. So where is my resultant of the two vectors now in this diagram? The resultant is here. This is the sum of the two vectors. So I can of course also work out by just applying some trick to solve the triangle, how much the magnitude of this resultant is, how much this is, and if required, I can find out this angle also. Okay. So anyway, so for that you'll have to drop this perpendicular and solve this triangle. So in this triangle, suppose this side is x and this side is y. Now you can see that this is a very easy triangle. The smaller triangle is very easy because this angle will also be 45. So x will be equal to y, which will be equal to b's magnitude divided by root 2. So that is nothing but 3. Okay, so these are the magnitudes of x and y. And now come back to the larger triangle. So for the larger triangle, what is happening? That this side is now y, which is 3, and this side is now a plus x, which actually becomes 4. Okay. And this side is the resultant, which we are trying to find out. So you can see it's the hypotenuse of 3 and 4. So the magnitude of the resultant, which is mod of a plus b, is quite simply by Pythagoras theorem 5. So that is how I would solve this geometrically. Okay, but here I actually did not need to do this much hard work. Now, that is the whole purpose of writing the formula of triangle law, that I don't need to do all that hard work. If I just know the value of theta, the magnitudes of A and B, then I can just substitute in the formula step by step, and that's it. I will come across the answer. Okay, so that is what the
law is all about. Okay, now let's also see how we can use this to find the angle. So let's add a second part to the problem above. Okay. So hopefully this is completely clear to you. So let's say this was now our first part, where we found out the magnitude. Okay, and also now we want to find the angle alpha of the vector A plus B with respect to the vector E. Okay. For example, the question is giving us the angle between A and B. But now what is the angle going to be between A plus B with A? That is what is asked in the second part. For that, we have to use that second formula. So along with this, we also have tan alpha is equal to B sine theta upon A plus B cos theta. So in the formula based method, I just have to substitute here. So this is 3 root 2 into sine 45, which is 1 by root 2, because you know sine 45 is also 1 by root 2 upon 1 plus 3 root 2 into cos 45, which is 1 by 2. So you can see that tan alpha is equal to 3 by 4 or 0.75. And if you look up a tan table, you will see that tan of 37 degrees is equal to 0.75. Okay. So this is a new value which we don't know as a standard value. Okay. I'll discuss more about 37 and 53, two important angles later. But just like you know that tan 45 is 1, or that tan 30 is 1 by root 3, or tan 60 is root 3. You know these values. So like that, there's another set of values. According to that, tan of 37 is equal to 3 by 4 or 0.75, 0.75. So if you use a calculator, a scientific calculator with the inverse function, or if you just use a log table which has the tan table at the back of it, the sine cos tan tables, then you can verify this also. So it will come out like this. So coming back to the triangle method, how we'll find this angle alpha now. So again, this is the angle alpha that we're talking about here. In the triangle, this is the angle alpha that we're talking about. So that is this angle. So you can see that tan alpha is y upon a plus x perpendicular upon base. So that becomes 3 by 4. And I just told you that tan alpha is 3 by 4. का मतलब ये होता है कि alpha कितना है 37 degrees. It's a standard angle actually. If you look up a table or if you use a scientific calculator, just type 37 in it and then apply the tan function. You will see it comes very close to 0.75. It is 0.74 something, but if you round it off, it comes to 0.75. So it is approximately 3 by 4. So that's okay. So this is the complete solution of this now, because we have found out both the magnitude as well as the direction of the resultant vector. So first we found out by formula method here, and then below here we found out the same thing, geometrical methods. Either method is equally valid, there's no problem with it. But again, it's based on the data of the question which method is easier. Is it easier to substitute in the formula and get the answer, or is it easier to actually visualize the triangle? And at this stage, you should try all questions by both the methods, and with time you will be able to figure out कि किसमें क्या ज़्यादा आसान है. Okay, people. So I hope this particular question is clear to all of you. Okay. Now next, what I'm going to do is I'm going to turn to the worksheet. Okay. So there are some specific questions of the worksheet which I will be discussing, and some other questions of the worksheet for which I will be giving you the hint today. Okay. Instead of discussing the whole question. Okay. Okay. So these type of questions where we are asked to find out. So I'm going to discuss some of the questions in full detail, whereas some of the questions I'm going to discuss in terms of just the hint to you. Okay, so I'm coming to the worksheet. So go through question number 1 and 2. I'm going to give you some hint for it. Okay. So that's what we are doing next, worksheet discussion. So that we start with question number 1. Okay. Now in question 1, see what is given to you. The magnitudes of two vectors are given. Okay, so magnitude of vector E, or you can just call it E in short, is given as, let us say, 3 and 4, right? So 3 meters, A is a displacement of 3 meters, and similarly B has a magnitude, or B is a displacement of magnitude 4 meters. Now we have to find the condition so that A plus B has a magnitude, okay, in the first part of 7 meters, in the second part of, I think it is 5 meters, is it? Or 1 meter? Okay, 1 meter. And in the last part, 5 meters. So अभी पहला चीज क्या है? We have to understand कि इसमें condition का मतलब क्या है? What do we mean by condition? So see, what information is given to me about the vectors, the magnitudes, but what is missing? The angle between them. So by condition, I basically mean what is the angle. I have to find out what is the angle between them. So for that, I have either the formula or the triangle concept. Now you can see what kind of combination of A and B is 7. So for example, for the first, you can see that 7 is actually the scalar sum of 3 and 4. Okay. So from that, you can easily realize without doing anything that means theta should be how much? 0. Because that's the only way the resultant can be the sum. The corresponding diagram is like this. If this is the vector A, then this should be the vector B. Because they are displacements, so that the resultant is becoming 7. This is the only way this is possible. The only way 3 and 4 can give you a resultant of 7 is if they are parallel to each other or they are just one after the other. Any other angle involved here, that would not be possible. Okay. Any other angle, that resultant would become, okay, my diagram is wrong, 4 should be longer, but don't worry about that. Yes. So this is A plus B, and the only way it can be 7. So this is like a common sense approach, because the moment you see 7, it strikes you that, okay, 7 is the sum of 3 and 4. So, you realize that, okay, displacements hai, so they must be continued in the same direction. So 7 ho hi nahi sakta. Okay. However, there is also a formula-based approach. Okay, and the formula-based approach is like this. You go by the formula method. They're like this, that magnitude of A plus B is equal to root of A square plus B square plus 2AB cos theta. Now we just substitute the value. So magnitude of A plus B over here given in the first part is 7. And these are individually 3 and 4. Okay. So this will become 2 into 3, 6 into 4, 24 cos theta. So from this you now solve. Okay. So you square both the sides. So 7 square is equal to 9 plus 16, 25. Okay. Plus 24 cos theta. So when you solve this, you will get cos theta is equal to 7 squares of 49 minus 25 divided by 24. So you get it as unity. So that means that theta is 0. You know that cos theta is 1 or theta equal to 0. So as you can see, what I was telling you, कि geometry ज़्यादा आसान है कि formula ज़्यादा आसान है. That varies from problem to problem. So in this problem, you can see that because directly you can observe that 7 is 3 plus 4. The geometry method was not convenient, is more convenient. You can directly visualize and understand. The formula-based method is unnecessarily lengthy. You have to solve so many steps, square both the sides, then find cos theta from that analyze. So that was not necessary over here in this. Okay. So hope this is clear. I'm just going through your messages while you work this out. Okay. Okay, very good. So now let us similarly see the second part. Second part is equally simple because in the second part you can see the magnitude is 1, which is actually the difference of these two. So you just visualize in terms of displacement. ऐसा कैसे हो सकता है that the A plus B is equal to a single unit or 1 meter, let's say, when A was 3 meters and B was 4 meters. So you realize that's only possible in this situation where if A is like this, then B is like this. Okay. So A is vector of magnitude 3, and in comparison, B is making an angle of 180 degrees with it. So you're actually overshooting the point that you started from, which was over here. And you're ending up with a net displacement or a resultant, which would be the same. The resultant would be, sorry, So anyway, coming back here, if B is this, then now your resultant would be this. This would be A plus B. And as you can see, this would be 1. So this was 3 meters and this was 4 meters. Okay. So again, this is how we visualize this. Okay. If you solve this by the formula method, it becomes a little bit more complicated. Okay. So I will come to that also, how you will do it by that method. Okay. Now, if you solve it by the formula method, I'm not doing the whole thing, but you will get cos theta equal to -1. Now, as of now, we don't know what to do with this. Cos theta equal to -1 का मतलब क्या होता है? But later in today's lecture, you will understand. Okay. So the way to solve this method, this question right now, okay, by according to what we have learned till date, is this method. You have to understand it this way. Similarly, you will see I'm giving you the hint for the third part. If you're taking mod of A plus B as 5, you'll realize the 5 is the hypotenuse of 3 and 4. So since 5 square is equal to 3 square plus 4 square, okay, whether you go by the formula method or the triangle method, it will be very easy for you to understand that the angle will be 90 degrees. Okay. Theta will be 90 degrees. You can use both methods. They both will be equally easy. So I'm leaving this to you. You work this out yourself, this part. So I'm just giving a quick reference to this. Now let's move on to the second question. Let's go through this once final time if you require, and then let us refer to the second question. Okay. Now, second question is a bit of an indirect question, okay, but again, not too difficult. So, what the question is saying is that you have two vectors A and B, both of which are of magnitude 10 each. Magnitude of A is 10, magnitude of B is 10, but the vector A is at 30 degrees to the x-axis, and the vector B is at 60 degrees to the x-axis. So you have to find the magnitude of A plus B. So all you have to do is here, you know mod A, mod B. You have to find theta between them. So for that, you just draw the two vectors and you will understand what is theta, the angle between them. This is your xy plane. Then you can see in this, the vector E is something like this. Its magnitude is 10, but more importantly, this angle is 30 degrees. Now in the same diagram, how does vector B look like? Vector B now looks like this. It's got the same magnitude of 10, but it's got a different direction. This angle is 60 degrees. Okay. Therefore, now the important thing is what is the direction between A and B. So for that, this is what you have to understand, that A का direction क्या है? ये वाला है, और B का direction क्या है? ये वाला है. So इनके बीच ये angle कितना है? This angle theta. That is how much? That is 60 minus 30. So that is okay. Or in other words, if you were to place these two vectors in a vector triangle, how they would look. So in a vector triangle, your vector E would be here. and your vector B in comparison would be like this. This would be the vector B, where this angle would be our theta. Okay. And this angle, as you can see from here, is going to be 30, because this is 30 and that is 60. So now you have to find which one? You have to find the resultant. So you have to find this. So this is also 10. Okay. So we can just use the formula, and theta is 30 degrees. So just use the formula. So mod of A plus B is root of A square plus B square plus 2AB cos theta. In that, just substitute. So we get 10 square plus 10 square plus 2 into 10 into 10 into cos 30, which is root 3. So you can take 10 common, and you have 1 plus 1 plus, here you have root 3. So you can leave the answer this way. It's 10 into square root of 2 plus 2. Okay, so this is okay to leave the answer. But if you want to simplify this further, you can do that also. So you can approximate this as 10 into square root of 2 plus 1.73, or 10 into square root of 3.73. And then you can again do a further approximate calculation of this. Okay, so anyway, I'm not really concerned with the calculation part further. Okay, the square root form is fine for now. So this is. So if you do take the square root and all, this will come approximately as 19.31. Okay, mod of A plus B will come approximately. So anyway, this is what you were expected to do in the question. This is all actually. Just okay. Incidentally, has anybody tried something else in this question, some alternate method? Okay, Ritika, I'm seeing your message about the angle part. Tiana, you got it correct. So which question you are referring to find the angle? This second question or the first one only? You can do that. You can start both the vectors from the origin beta. That's correct. Rahil Modi, you can do that. So you can draw the vectors this way also. There's no problem. So in this, your vector E would be here at 30 degrees. Okay. And your vector B would be here, where this angle would be 60. Okay. So again, the angle between A and B, you can see this is the direction of A, this is the direction of B. So the angle between A and B would be this angle. This is the angle theta. So that would be 60 minus 30. Okay. But, and now you apply the formula. So you take mod A as 10, mod B is 10 given to you, and theta, the angle between them is 30 degrees. And now you substitute this in the formula. Okay. Or you draw that vector triangle. Now convert this to a vector triangle. So when you convert to a vector triangle, remember you cannot draw both the vectors from the same origin. They are displacement vectors. They are happening one after the other. So you will have to pick this vector up and place it where? Place it over here. Yeah, in question 2, beta, the angle has not been asked, but if you're asked, you can find it. Okay, I'll explain how. Actually, the angle will be 15 degrees. That is why it will come out to be an unknown quantity. Okay, but you can use a trick in geometry. Okay. So I'm just coming to that. So I'm just showing you something interesting here before we move on. there is another thing we could have done over here, which is a little out of the box. It's not something that straight away comes to mind, but it's like this, that see, A was a vector of magnitude 10, B was a vector of magnitude 10. Okay. So this side was equal to this side. And this angle here was 30 degrees. Okay. So now when we are trying to find the resultant, which is this side, we can use a trick over here. See, this is which kind of triangle? It's an isosceles triangle. So we can use the property of isosceles triangle, that whenever you have an isosceles triangle where, I mean, this one looks more like a equilateral triangle. So let me be more specific. So suppose we have an isosceles triangle which is something like this. Okay. So what happens is, if this side is equal to this side, then this angle becomes equal to this angle. So this angle and this angle become equal. So that is one property. Okay, two angles are equal because two sides are equal. And the third thing is that if you drop a perpendicular from here, from the vertex of the equal sides, then it bisects this third side. So if the third side is y, for example, this becomes y by 2 and this becomes y by 2. So we can make use of this property of the isosceles triangle. So how we can make use of that over here is, if you drop this perpendicular. Okay. So because this side is equal to this side, this angle is suppose alpha, this angle is also equal to alpha. And not only that, now we can see that the sum of the interior opposite angles is equal to the opposite, exterior opposite. So alpha plus alpha is equal to 30 degrees. So that also tells me that alpha is 15 degrees. That's right. Okay. So now you can also see that with respect to the x-axis, how much angle this vector is making. This is my x-axis. So my resultant vector R, if I wanted to make its angle with the x-axis, that would be 30 plus 15. That was not asked in the question, but in case you were asked to find out this angle, in case you were asked to find out, let's say, this angle from here to here, this angle is, let's say, some beta or something. You can see that beta will actually become alpha plus 30. So it will become 45 degrees. Okay. Because this angle here was 30 degrees. So we could have used that trick if we wanted to solve for the angle. But that was not necessary in this question, so I'm not getting into it. Okay. So that's anyway the second question. Now let's all of us turn to the third question. Third is an easy question, so I'm leaving it to you. Why third is easy? See, in third question, again you have the magnitudes of 5, 12, and 13. Okay, and you have the relation that 5 square plus 12 square is equal to 13 square. So it will be a right angle triangle. Okay. So just use that as a hint for the question. Okay. Let's come to the fourth question. Now, fourth question is a little tricky, so I'll explain it in detail. Okay. So the fourth question, language is tricky. First of all, it says that two forces of equal magnitude act at a point. Okay. So let's say we have forces F1 and F2. Now the first information is that their magnitudes are equal. So they are such that magnitude of F1 is equal to magnitude of F2 is equal to, suppose we denote that as X. Suppose we say, let that magnitude just be X. So that is the first information given. And it is also given that the square of the resultant's magnitude is 3 times their magnitude's product. Okay. So the resultant का magnitude का square is how much? 3 times the product of their own magnitudes. This is the information that is given. Okay. Where R is nothing but the sum of F1 and F2. So this is, or we can simplify this and say that okay, R square is equal to 3 times x square, or r is equal to root 3 times x. You cannot take r as a negative quantity because it's the magnitude of a resultant. So here, if a square is equal to b square, it means a is equal to plus minus b, but here we won't take the negative root because it's just a magnitude. So this is what the second line is telling us, whereas this is what the first line was telling us, that the magnitude of the two forces are equal. So suppose we take them equal to x each. So we are getting a statement that mod f1 is equal to mod f2 equal to x, and the square of the resultant's magnitude is 3 times the product of the. So that is giving me this, that the resultant's magnitude is in terms of x, it is root 3x. Okay. So now using this, can we solve for the angle? Solve for theta, that is the angle between them. So now just think how it. So I've broken down the problem for you to such a form that now you should be able to solve it yourself. Just try this out, people. What was tricky in this question was, how to understand the language of the question. So that I've broken down over here to this. Now you should be able to solve it from this point onwards. Yes, so correct. That's correct. The angle will be 60 degrees, correct. Okay, just try this out, people. Okay, so people, very good. Samaru, you also got it correct. So all you have to do is substitute this in the formula, and you can see we'll get this. So if we have that R is F1 plus F2, okay, the formula is that magnitude of R is square root of that one. Same formula, just rewrite it in terms of this. Okay. So R is given to us as root 3x, and F1's magnitude is equal to F2's magnitude, which is x. So substitute this here. Substitute and then find theta. So you can see that root 3x is equal to, you will get x square plus x square plus 2x square cos theta. So square both the sides and do all those steps, and you will get cos theta as half. So that means theta is equal to 60 degrees. Okay, people. So hope no difficulty now with this type of problem. Okay. Now moving on. Yes, you can also, Varun, that is correct. You can use the property of isosceles triangle also to solve this. Okay. And you can try that out yourself. Okay. It's a nice little exercise for you to do yourself. And if you have any difficulty when you're solving using that method, you can just send me your working on WhatsApp and just take a click of your notebook and your working, and I will help you out with the steps. Okay. Okay, so fourth is done. Yeah, now fifth is a very interesting problem for which I am now going to give you a hint. Okay, fifth problem, many of you might not have been able to solve because you didn't understand how to convert the question into useful information. So I'm just going to help you with that today and still give you a chance to solve the problem yourself. Okay, because it's a very interesting problem and I don't want to just break the problem up for you altogether. So this is a carom board which is 4 feet, I believe, by 4 feet. And okay, and it has pockets, on all the corners. And the idea is to be able to pocket the coins. Okay. Now the information given in the question for us is that the queen coin, which we will basically treat like a particle over here. We won't get into the size of it, but slightly larger than a particle, is sitting right at the center. And what we want to do is we want to hit a rebound shot. So rebound shot ka matlab kya hai? That we are going to make it rebound or collide with the front surface and come back. So the path of it will have to be like this. The path of the coin will have to be something like this. So let me try and draw this correctly. It's challenging. So I'll draw some guidelines here to understand this better. So first of all, let me draw some symmetry lines here. So that we get the midpoint of the board or the centroid correctly. So these are the bisectors of the side, let's say. Okay. So this is where your coin was sitting in the center over here. So from here it has to take a path which is something like this. So the path of the coin has to now be something like this. It has to rebound off this surface. Okay. And then from that rebound point, it has to come back somewhere. Okay. So this actually has to be the path that this thing takes as it rebounds. Okay. All right. So if our queen coin was sitting here, let's say this centroid point is O. Okay. You have to aim it at some point over here correctly so that it can take this kind of path. It can rebound off this path and come back and hit this corner. So let's label the corners also. So suppose the carom board's corners are E, B, C, and D. Okay. And also this midpoint here is E. Okay. So just to give you perspective, like when you're playing carom, you'll realize that if you're trying this kind of rebound shot, okay, now if you make a mistake of keeping the point where you aim too much to the right, then you'll end up having a path like this. So this will not work out. Okay. Or if you make the mistake of aiming the point at the point P somewhere over here, which is too much to the left, then something like this might happen. It might rebound like this. So again, this will not work. There's an exact point where you have to aim so that the rebound will result in this. Okay. So here we'll assume that to find that point, you make use of the logic that the rebound at the point P is like a mirror reflection. So as you know, the reflected path of light, it follows the thing that angle of incidence is equal to angle of reflection. So that means if it is like a symmetric reflection, then this angle here, theta, should be equal to this angle here, theta. So that is what I will take advantage of. Okay. And then the next thing I will do, so what you've been asked to solve in the question is, you've been asked to find the displacements of the coin from the centroid to the front wall. So that is nothing but the vector OP and the vector from O to P. This vector you have to find in terms of magnitude. You've been asked to find this. Then you have to been asked to find the displacement from the front edge to the pocket at the back. So that is PC. That means this vector here from P to C. ये वाला vector P to C. This vector. This one's magnitude you've been asked to find, and the magnitude of this vector from O to P. And you've also been asked to find the final displacement, which is nothing but from O to C. So that's another thing you've been asked to find here. O to C is very easy, as you can see, it's half the diagonal, so that's no problem. So the side length is 4, so the diagonal is 4 root 2. So half the diagonal is just 2 root 2. That's easy. The tricky part is these two: how to find OP and then how to find PC. So to find these now, the further hint that I'll give you, one is already I've given you that you have to treat it like a mirror reflection. Okay. The further hint that I'll give you, the moment my whiteboard stops misbehaving, just a moment, I'll reshare the whiteboard. Yeah, just give me a moment. Coming back to this. Okay. So one hint I've already given you. The other hint I'll give you is that in the above diagram, I'll just show you that triangle OPE, okay, and triangle PVC are similar triangles. No. They're similar right angled triangles. So make use of that, similar triangles. So for example, perpendicular upon base should be equal to in the other side perpendicular upon base, or perpendicular upon hypotenuse should be equal to on the other triangle perpendicular upon hypotenuse. So this kind of logic you can use. So I'm just minimizing this so that you can refer to the triangles which I'm talking about. Okay, so two hints we are making use of. This is the hint one, that it's acting like a mirror image, the rebound. So that's why these two angles are equal. So theta is equal to theta, that one. And the second hint is make use of this, similar triangles. Okay, so that is geometry of similar triangles. So it's still an interesting problem. I have not solved it fully for you because I want you to have the satisfaction of solving out the question yourself. So use this and try to work it out. If you still have difficulty, you can always WhatsApp me today, tomorrow, whenever, and I will give you the required solution. Okay, people, so that is the fifth question. Now we'll move on to the 6th, 7th, 8th, etc. So coming to that, just first absorb all this information. Right, so hope this is clear, people. Yeah, Somarup, to answer your question, actually the part depends on a lot of things. Not only the where the striker is placed, but how the striker is hitting the coin. No, so technically we'll understand all these things in future in a chapter called collisions. If you look at any standard class 11 textbook, you will see that there's a chapter called collisions where we understand these things in detail. But so hope this part is clear now. Just to give you a perspective of that thing, that how the striker's position and the angle at which the striker goes hits, all this matters is like this. Suppose your queen is a coin like this. Now, this is not related to vectors just now. It's not part of our syllabus for the moment, but just out of interest I'm telling you. Now suppose this is the particle that you're hitting and you're using the striker, which is like a disc like this. It's a slightly larger disc, let's say, to hit. Now, after the striking, how this will go, that all depends on a lot of things. It doesn't depend just on this thing. It doesn't
depend only on this distance. It doesn't depend only on this. It doesn't depend only on y and x. It also depends on another thing, the velocity vector. So, we have basically started that journey where we understand vectors. But, for example, if I hit it like this, so it is going along this path. So if it is going along this path, so what will happen is, this is more like a tangent kind of shot. Okay, so if you played carom enough, you will recognize what I'm saying over here. That when this comes here, this will be something like this. Let's see. So at the time of striking, it will be like this. Okay, so what will happen is that this will, because of the, now this is going in this direction. Okay, but that doesn't mean that this will go in this parallel direction, because इनके बीच जो impact हो रहा है वो किसके along हो रहा है, इसके along हो रहा है. Okay, so the so-called what we call impulse, that is force into time, as they come in contact, they're in contact for a very brief time, like a nanosecond or something. But during that time, this body, the let's say the body A, is applying a force on the body B, which is not along its own momentum vector. It's not along this vector. It is actually along the center to center line. So what will happen is, as a result of that, this coin will go off like this. It will go off along this direction. So its path of motion will be like this. So that's why it doesn't just depend on x and y. It also depends on this. So for example, instead of this, if the velocity vector of this one, now in this diagram, this was the velocity vector of this. So if this is hit with a velocity VA like this, so as it strikes, it's hitting with a velocity VA, and it is giving the second one a velocity VB like this. Okay. But for example, if we are taking a different case where, let's say, this is your coin and this is the striker. Now suppose I had given the striker a velocity vector which is like this, now more direct kind of thing. So it's like this. This is like what in common language you will call as a straight shot or a direct shot, whereas the one on the left is, in common language we call it a tangent shot. So here, when this comes in contact, it will be like this. It will be like this. So what is happening is, it's going to hit it such that now the final velocity of this guy will be along this direction. This coin, or we can call it the body B, is going to have a velocity in this direction, because here the center to center line was the same as the direction in which this was moving. So here this will happen, whereas here something like this will happen. So this is an example of what we call a tangent shot. In carom language we call it tangent shot, but in language of collisions later we'll see this is called an oblique collision. You are hitting this obliquely, whereas here in language of caroms we call this a direct shot. Okay. But in proper language of collisions, this is what we call a head-on collision. You're hitting it head-on, straight, whereas there you are hitting it obliquely. So each has its own set of properties and all that. Okay, but yeah, coming back to that question we were discussing, we are not concerned with this actually. We have understood that we have achieved the position of the striker and all that correctly from somewhere here, and we are hitting it so that this is achieving this path. But it has to achieve a path so that the mirror image reflection results in a reflected path which brings it to this corner C. That is the important thing in the question. So we have to hit it with an angle and all that such that it goes with the proper velocity's direction, and therefore it rebounds with the proper direction, which makes it come and get pocketed over here. Okay. So just for that, we have to see that how to find the displacement from here to here, which is OP, and the displacement from here to here, which is PC. And for that, we are making use of this
this geometry over here. Okay, so in fact, this question in that sense, you can say it has more parts which we haven't discussed about here, more aspects to it, like the impact with the striker and all that. And that we can come to at a later stage when we discuss about collisions, etc. Okay. But right now, from vectors, what we can analyze before we discuss collision and all that few months down the line is this much. And this is interestingly how you can understand what is happening. Yes, it is very difficult. That is correct, Aman. And you know how players make it and all is with practice. It's not that they know their physics that well. They're not sitting and calculating, and even calculating will not help now, because ultimately your finger has to be able to execute it properly. So for that, it is more about practice for the game. They develop an instinct with practice. But you will see a lot of sports and you know this thing, games, etc., where there is precision involved. At the end of the day, it is application of physics. Whether it is spin bowling or it is penalty shootouts or things like that. Okay, very good, Tanish. So as I said, I'm giving you guys some more time to solve this question out yourself. Okay, the answer key is already given to you, so you can verify the answer. But if you have any difficulty further, you can discuss. Okay, now next sixth question I'm not going to do because it is very easy. In sixth question, what I recommend is you just make a vector diagram. So make a diagram where you represent each of the displacements given in sixth question, like 2 kilometers towards east, then 500 meters towards left turn. That means you go from east towards north. Okay, then again 4 kilometers after making another right turn. That means from north you again point towards east. You make a displacement of 4 kilometers and you stop and all that. So I'm just leaving you with that question to solve yourself. Seventh question is the next one we will look at. And in seventh question, directly a diagram is made for us. So come to the seventh question, and you can see in the diagram, the vectors A and B are of same magnitude 10 each, whereas they are oriented to the XY axis as I've shown you in the diagram. So from that, we have to find the resultant of the two, which is the vector C. C is the sum of A and B. That means it's the resultant. It is A plus B. So we have to find the properties of C from the given diagram for A and B. So let's tackle this problem now. Seventh question. So first of all, let's understand the diagram in the seventh question. So with respect to my XY plane, two displacement vectors E and B are drawn from. At an angle of 60, so it should be more like this. Oh, sorry, it's at an angle of 30. It's correct. It's like this only. So this is the vector E. Its magnitude is 10 units. Now my second vector B is now like this. It's at an angle of 120 with respect to this. And it's also magnitude 10. So this is also magnitude 10. But its angle with respect to the direction of A, this angle is given to me as 120 degrees. And of course, A's angle with the x-axis is also given. That is 30 degrees. Okay. Now from this information, what is given to us is, if the vector C is the sum of A and B, or the resultant of A and B, then we have to find magnitude of C and its angle. So C is equal to A plus B. We have to find magnitude of C and the angle of C, but not with respect to E, but with respect to the x-axis. Okay. So in the diagram, what does that mean? That in the diagram, it means that my vector C would be lying here from the base of A to the tip of B. So it would be lying something like this. And I have to find out what this magnitude is, and I have to find out what this angle is, this total angle. Suppose this is some angle beta. So I have to find this out. I have to find C and I have to find beta. Okay. Now let's do one thing. Let's first think that, okay, if I use triangle law, I have magnitude of A is equal to magnitude of B is equal to 10. So that's given. And I have theta equal to 120. But the problem in triangle law, I'll have to use cosine. And as of now, cosine of 120 might be a problem for us. Okay, I'm going to teach you how to work this out also. But just now, after my first lecture of vectors, there was no information about how to get cos 120. So this becomes a problem. I can't use the triangle law. So I have to go with what? I have to go with geometry. So if I've got to go with geometry, I have to solve the triangle above without using any formula. But notice what kind of triangle it is. It is isosceles triangle. So this is where I'm going to take advantage of my isosceles triangle concept. Okay. So coming back to that triangle, I'm just redrawing it quickly. So in that triangle, I had one vector E like this, and another vector B like this. The important thing is this angle was 120. Okay. And another important thing was that these two sides, A and B, are equal. This side is also 10. And this side is also 10. So when I now figure out my third side, I can take advantage of the fact that first of all, I'm dealing with a so-called isosceles triangle right now. So these two sides are equal. That means these two angles are equal. So these two angles are, let's say, alpha each. Okay. And the sum of the interior opposite angles is the exterior angle. So that's 120 degrees. So I'm taking advantage of that. So now you would have guessed the answer. Okay, what is happening here? The moment your alpha is 60 degrees, so you can see that then it is an equilateral triangle. Okay, so equilateral triangle, because if these two are alpha 60, then automatically this also becomes 60. Because beta, which is 180 minus 2 alpha, becomes equal to 60. This is alpha. So it's equilateral triangle. So that means this side is also equal. So that means C is equal to A is equal to B is 10. So the magnitude of the vector C is 10. Okay. And now the next thing is we wanted to find out this whole angle. So I wanted to find out, let's say, this angle here. This angle is, let's say, theta. So you can see that is very easy now, because this angle was 30 degrees. So that theta is 30 degrees plus alpha. It is nothing but 90 degrees. So that also shows you that the vector C is at 90 degrees with respect to x-axis. Okay, so that is why I had given you the question, in spite of the fact that I have not taught you how to find out cos of 120 yet, which I will be teaching you now. Okay, because every time we won't be able to get away with geometry like we've done over here. So we will come across situations where we actually need to substitute cos of an obtuse angle. So that is in fact going to be the second part of this lecture, what we learned today. Okay, coming up very soon. But still I had given you this question, why? Because it can be solved by using this geometry. But just that you have to be mindful of, how to apply the geometry of isosceles triangles, and then from that you are recognizing that it's not only isosceles, it's in fact a equilateral triangle. So this is the part of vectors that I actually find interesting, that solving vector triangles, later vector parallelograms, etc. We can make use of a lot of very interesting little things from geometry that we've learned earlier, and incorporate that into our solutions. So the problems become you have to use your creativity while solving. Okay, so hope this is clear to you all now. Okay, eighth question, I'm just going to give you a short hint. You'll be able to solve it yourself. Ninth is again a slightly tricky question, so we'll discuss in detail. Okay, so moving on. Just a second, let me. Okay, guys, just give me a minute here. I have to. Refresh my whiteboard software. It's not hanging. Just in the process of restarting it. Okay. Okay, so ninth question, as I said, I'm just giving you a quick hint. Ninth question is about the minute hand of a clock as it moves. So let's imagine this is actually the minute hand, and it rotates about this end over here like this. So this is, let us say, 15, 12, 30, 12 or 0. This is 45. This is 16. So that thing, it rotates like this. It's a perfect circle actually. I'm not drawn a perfect circle. It goes like this. Okay. So for example, when it goes from some hour, let's say X hours, 15 minutes, to that same hour, 30 minutes. Okay. So the tip of the minute hand is going from here to here. It is going from this position to this position. Like this one. So the displacement, so this is at, so the displacement vector of the tip of the minute hand, that is how much? That's this much. This is the displacement they're talking about in the question. This is the displacement for the tip of the minute hand from 15 minutes some hour to 30 minutes past that hour. Whatever that hour is, it's 3:15 to 3:30 or 2:15 to 3:30. So that displacement you can see very easy. It's 90 degrees if this length is L. So the magnitude of that displacement is L root 2. That's it. That's all you do. Similarly, in the next half an hour, it will go from here to here. So that time you can see the displacement is this diameter. So it just becomes 2L. And in next 1 hour, it comes back right up to where it started. So the displacement becomes 0. So that's how you answer the second and third part. So this, I think, is the 8th question. Sorry, not the 9th question. This is the 8th question. Okay. About the minute hand of the clock. Now let's come to 9th question. Now 9th is again a question which is tricky on language. So let me explain the question properly. So it says that resultant of two vectors P and Q is R. So the first thing it says is that the vector R is the sum of the vectors P and Q. Whereas it also says that on reversing the direction of q, the resultant of this vector minus q with p is equal to s. So what does this statement mean? That s is some vector which is the resultant of the vector p, but with which vector? The vector minus q. In other words, it is p minus q. So first let's understand what this operation means. Okay, the second one. So let's go back to our diagram method. If this is the vector p, suppose, and this is the vector q, they have some magnitudes capital P and Q, and the angle between them is some theta like this. Now, what do we mean by the vector minus Q? What is the vector minus Q? Minus Q is a vector which has the same magnitude as Q. Okay, because minus Q is nothing but the scalar quantity minus 1 multiplied with the vector Q. So you're multiplying a quantity whose magnitude is 1. That's why its magnitude will be the same. But direction will be what? Opposite, because you're multiplying the negative quantity. But direction opposite to Q. So this is what we understand. So if this is the vector Q, which is the vector minus Q in this diagram, now the vector minus Q will be like this. It will be exactly opposite. It will be like this. This will be the vector minus Q. It will have the same length, the same magnitude as this, but it will have the opposite direction. Okay. So now from this diagram, let us understand what are my R and S. Okay. So the vector R was the sum of P and Q. So just pick up those two vectors from the top, okay, and draw your normal thing. So it's like this. So in this vector diagram, this would be my vector R. Where these two vectors are P and Q. And this angle is theta. But what would be my vector S? It is the resultant of P and minus Q. So how I would do that operation? So I'd keep the same vector P. I'd pick up that same vector from the top P. But now to add to P, which vector I would take? Not Q, but I would take the second vector, which is opposite of Q. So I would take this one. This is the vector minus Q. Whereas this was the vector P. Okay. So in this diagram now, you can see between the direction of P and Q, Q's direction was the dotted line here. So this angle was theta given to me, same as this. So here, this angle actually becomes theta because this angle is 180 minus theta. This angle here is 180 degrees minus theta. So that is why that interior angle here becomes theta. Now, finally here, which is my vector S? It is the sum of P and minus Q. So it is P plus of minus Q. So it is this vector. So this vector is my S. Now, see in the question what I have to do. In the question, I have to find a relationship between. So now I want to solve for the relationship between magnitude of R and magnitude of S. It's a proof question, but it's about the magnitude. So see, from triangle law, you already have this magnitude. It is R is square root of P square plus Q square plus 2PQ cos theta. But as of now, I don't have the relationship of S. So what I'll do is, I'll do the same treatment to this triangle like I've done here and solve using trigonometry. So I'll solve this triangle now using trigonometry. So let's see how we'll do that. So in that triangle, just redrawing it. This side was P. Just a moment, guys. Just a moment, I'll restart the software. Okay, so hopefully the diagram is back for everybody. Okay, so this side was P in my diagram. This side is some S. In length. This angle is theta. And now I have to find out this third side. Sorry, the third side is S, my mistake. This was the vector S, so this side is S, whereas this was the vector minus Q. So its magnitude was Q, and this angle was theta, and this is the vector P. Okay. So next what we do is, we drop a perpendicular from here, just like we've done earlier. But when we drop a perpendicular this time, this side will become X, let's say. This side is Y. And on this side, this remaining is how much? It is P minus X. Okay. So now applying trigonometry to this triangle here, you can see that X upon Q is based upon hypotenuse, so it is cos theta, whereas Y upon Q is perpendicular upon hypotenuse, so it is sine theta. So X is becoming Q cos theta, and Y is becoming Q sine theta. So up till this point, it's very similar to the derivation we've done earlier. Okay, but now what about this other triangle, this one? So when you're solving this, the hypotenuse S is square root of P minus X whole square plus Y square. So we substitute these over here. Okay, substitute these over here, and you see what kind of relation now you get for S. So hope you have understood this. I'll just minimize this and do this final working yourself. It's pretty easy, just like we've done for the sum of P and Q, like that. For the sum of P and minus Q, the only difference is there it would have been P plus X whole square plus Y square. Here it is becoming P minus X whole square plus Y square. So a subtle difference in the two formula will come. And that is why S has a different formula compared to what my resultant R was. And when you compare the two formulae, you will get, you can see you can very easily come to the final step of the question, which is the proof part. So I'm just asking you to solve this final part yourself and tell me how much you will get R in terms of P, Q, and theta. Yeah, Aditya, to answer your question, we can use triangle law to find out the resultant of P and minus Q. But again, in that, we will have to use a formula of cos 180 minus theta, which I haven't taught you yet. So that I'll be teaching you in the rest of today's lecture, and you'll understand. In fact, there is a second part of triangle law, which is directly used for calculating the difference of two vectors. What we have learned so far is like the first part of triangle law, which is for the sum of two vectors. Very good. Wherein that's good to know you have understood how to solve. And you're getting the answer also good. Okay. So that in fact there is the operation that we are doing over here, P plus of minus Q. This operation that the vector S is actually P plus of the vector minus Q. In other words, it is the operation of difference of two vectors. Okay. And the formula we are developing here just for the question is actually going to be the formula for the direct method also. So just like we have a direct method of sum of two vectors, we'll also have a direct method for difference of two vectors. Okay. But here we are just doing it in the form of a question to give you practice. So anyway, on substituting all this, you will get S as root of p square plus q square minus 2pq cos theta. Whereas your r from above was root of p square plus q square plus 2pq cos theta. So now if you just square and add these two terms, you can see that r square plus s square. So left hand side is this thing square plus this thing square, become this whole term whole squared added with this whole term whole square. So your cos theta term will cancel and you will get 2 times p square plus q square. And that is what we were asked to prove. So that is this. Okay, people. So hope with that the approach for this question is clear. Okay. Now the 10th question I'm going to leave for you to do because it is very similar to another question we've done before, and that is the I think this 8th question or the 7th one, the one which had the triangle with 120 degrees outside and it became an equilateral triangle. So the 10th is identical to that equilateral triangle problem. So if you just review that, you will be able to do 10th yourself. Okay, so try out the 10th question yourself. If you have any difficulty, you can contact me directly. I'll help you with it. Okay. So now let us move on to the next part of the application of vector algebra. So next thing, very important, which is actually a little aside from this. Yes, right, that's correct. For the 10th, the answer will be 120. That's correct. Okay. So now we are moving on to how to find trigonometry for general theta. That means theta can be anything between 0 and 360 degrees. Or sometimes it is also called trigonometry in 4 quadrants. In maths, you will also read this as something called ASTC rule and all that. We will see how to make use of that. Okay. So the initial aspect of this is we will redefine sine theta, cos theta, and tan theta. We'll redefine what these mean. Okay. So in that we'll see that there are 2 different ways. One is in a right angle triangle. And the other is with respect to XY plane, or this is called the projection method. So this is just in terms of definition. So I'll explain what this means. Okay. So in a right angle triangle, we understand it's like this, that you have any arbitrary triangle where this angle is 90 degrees, this angle is theta. Then we label this as the hypotenuse, this as the perpendicular, and this as the base. And the definition of sine cos tan is simply that sine theta is perpendicular ratio with respect to hypotenuse, cos theta is basis ratio with respect to hypotenuse, and tan theta is perpendicular ratio with respect to base. Okay. So these are the definitions that you learned till date about trigonometry. Now you can see, because here you are restricted to a right angle triangle, so theta has to be acute. Okay. Because one of the angles is already 90 degrees in the triangle. So the sum of the other two angles is 90. So sum of all three is 180. So how can this be greater than 90? It's not possible. So you are restricted to one situation, that it has to be an acute angle. Okay. But next what we will see is a new definition of sine theta, cos theta and tan theta. This is what we are learning today, okay, which is not something you have probably seen before. Some of you might have, but so here we will learn theta as a different thing. It's not with respect to a right angle triangle. We will learn theta with respect to an XY system. And from that, we will understand what is sine theta, cos theta, tan theta. So we'll see that if you keep something like a rod or a line like this. Okay. So this is of length L, inclined at an angle theta with respect to the x-axis. This is what we mean by the term theta. So the angle theta is the angle of inclination, okay, of, let us say, a rod of length L, but with respect to what? With respect to the positive x-axis. So this is the most important thing here. That what is my meaning of theta? It is not some angle in a right angle triangle. Theta is the angle at which that particular rod of length L, which I have drawn over here, is inclined with respect to the x-axis. So now we can see theta need not be just acute. Okay, we can have a situation where theta could be obtuse also. So to just illustrate the point, you could have a situation like this. Where the rod could be inclined in this manner, something like this. So for example, here, could have an example where theta is 120 degrees. And we can also say it is 240 from backwards, but remember theta, the sign convention that we use is that theta is positive means it is anti-clockwise. Theta is negative means that it will be clockwise. So if I say 240, it will become clockwise. So it will become minus of 240. So this side it has to be expressed. Okay. So this is an example of theta equal to 120 degrees. Similarly, we can take an example where theta is, let us say, something like 210 degrees. So how will that look like? So that will look like something like this now. So 210 means that the rod is over here, somewhere here like this. And this whole angle, this one, this angle is 210 degrees. Okay. Similarly, theta could be in fourth quadrant also. So first of all, before we come to sine, cos, tan, okay, let's understand that in an XY system, okay, for our projection method which is coming up, what do we mean by an angle? So this is the definition of an angle. And that is why the angle can be acute, like in this example. The angle can be obtuse, like in the example below 120 degrees, or the angle can be even larger than obtuse, like it can be between 180 degrees and 270, which makes it in third quadrant. Okay? It can be between 90 and 180, which makes it in second quadrant. It can be between 0 and 90, which makes it in first quadrant. So these are the various different types of angles possible. So now we are talking about the context where an angle could be anything between 0 and 360 degrees. Now, it's a general angle. Okay, so I'm just leaving you with a few seconds to absorb this information first. Note it down if you like, and you will have the whiteboard notes available, don't worry, but still. So understand that, when we are talking about right angle triangle, we are very restricted. Theta cannot be greater than 90. In fact, theta cannot be 90 also. It has to be less than 90. But when we are talking about the general angle theta in terms of an XY plane, then theta can be anything. It can be acute, obtuse, it can be in third quadrant, it can be fourth quadrant, etc. Okay. So this is the meaning of theta. Okay. Now, once we have understood theta, let us understand how we define sine theta and cos theta. Okay. So what is sine theta, cos theta, and tan theta in the XY plane? So that is why we define So these are defined. So I'll explain projections. Okay. No, see, the thing is, you cannot express 120 degrees as 60 degrees. I've got a question in the chat. Okay, that can we express theta equal to 120 as theta equal to 60? That is not correct, because see, theta equal to 60 means that this angle is 60. Okay, this is theta equal to 60, and theta equal to 120 means something different. It means this angle is 60. So how we express theta? This angle has to be 120. So therefore, theta is 60 is not the same thing as theta is 120. They are two different angles. Because how we are defining the angle theta is the anti-clockwise with respect to x-axis. Be very specific about that. It is with respect to the positive x-axis. This angle is 60 here. This one, it is basically what? It's a clockwise angle with respect to the negative x-axis. So it's some different angle. It is not what we are defining as theta. So I hope this point is clear, that we cannot confuse theta 120 with theta 60. They are two different things altogether. Okay. Now let's understand the next thing, projections. Okay. So projection का मतलब क्या होता है? Let's get that clear. So if we keep a rod or a line inclined at an angle theta to the x-axis, okay, then next thing what we do is we drop two perpendiculars. So we drop a perpendicular from the rod onto the x-axis, and we drop a perpendicular from the rod onto the y-axis. Okay. Then this length over here, that it's like a shadow. It casts a shadow on the x-axis. Imagine there's light thrown vertically on this rod, so it will cast a shadow on the x-axis. So that is called the x projection, or that is called the projection along the x-axis. And similarly, if you throw light horizontally over here, it casts a shadow on the y-axis here. So that is called the y projection. So the term projection becomes important for us now. Okay. So the next thing is projections. X over here is the projection of the rod's length L on the x-axis. Okay. And Y is the projection on the y-axis. So you can even think of it like this, that if the end point of the rods has coordinates x comma y, the x coordinate is nothing but the projection on the x-axis. The y coordinate is nothing but the projection on the y-axis. So that's the next thing, how we define projection. Okay. So you've seen how we define theta. Now next we've seen, so in this example, theta is in the first quadrant. Okay. So both the projections are positive. Okay. But for example, if we take a situation where theta is in second quadrant, now if we take this example here, theta is like this. It's in the second quadrant. Okay. Because theta is greater than 90, but at the same time it's less than 180 degrees. So it's like, it falls in the second quadrant. So here if you see, the shadow that the rod is casting on the x-axis is falling on the negative side. So the x projection will be a negative quantity. Okay. Whereas the y projection is throwing is on the positive y-axis. So the y projection will be positive. So like that, each quadrant has its properties. The first quadrant, both x and y are positive. The second quadrant, x is negative, y is positive. So like that, you will also be able to understand. In the third quadrant, x is also negative, y is also negative. Okay. And in the fourth quadrant, x is positive, whereas y is negative. Okay, so these are your quadrant rules. Q1, quadrant 1, x and y are both positive. Second quadrant I've just written over here. So I'll just repeat it over here. Second quadrant, x is negative, y is positive. Okay. And third quadrant, the rod would be here. So you can see x and y are both negative. And fourth quadrant, the rod would be somewhere here. So the x projection would be positive and the y projection would be negative. So I'm just leaving this for a moment for you to absorb. Okay. So this is what we mean by projections. Okay. So we will next define sine, cos, tan in terms of projection. So for that, first we should understand what is projection. So projection is like a shadow of the rod along x-axis. That is nothing but the x projection, and along y-axis. That is the y. That is the meaning of the term projection. Okay, and just absorb this information along with the last part where we can see the algebraic sign of the projection in the four quadrants. Okay. Where x is positive, where x is negative, and vice versa. Where y is positive, where is y is negative. Okay, so hope with this the definition of the term projection is clear to you. Yes, Varun, to answer your question, you can take 120 as 16 to 2. But as we'll see later, more useful will be to write 120 as 180 minus 60. Okay, that's how we'll relate it trigonometrically. So I'm coming to that part now. Okay. So now next thing, once we have understood what is a projection, we will see sine theta, cos theta, and tan theta in terms of projection. So to define sine theta, cos theta, and tan theta, what we do is we take projections x and y of a standard line or rod. So what I mean by a standard line or rod is that its length is taken as unity. Whatever a system of units, can be 1 inch, it can be 1 foot, it can be 1 meter, whatever. But just to standardize our definition, we take the rod as if it is of length unity. Okay. So now on the basis of that, how do we define sine theta and cos theta? Let's understand. And tan theta. So this is going to be like a new way for us to define sine theta and cos theta and tan theta. Till now we've been used to defining it in terms of, perpendicular upon base, perpendicular upon hypotenuse, things like that. But now we will see a different way of defining it. Okay? So we are taking a standardized rod whose length is now unity. So length is 1 unit. Okay. And remember, when we drop the perpendiculars on the two axes, then this over here is x, okay, and this over here is y. So y is the same as this also. You can see this length here is y, and this angle is theta. So we actually define x as cos theta, and we define y as sine theta, and we define x by y, sorry, y by x as tan theta. This is the definition now. So from now on, we will interpret sine cos tan by this. Okay. So these are our definition. Okay. In terms of projections, but of which kind of thing? A standard rod. Projections of L equal to 1 unit. Okay. Now you see that this comes in nicely with respect to trigonometry of right angle triangle also. Because if you just see this right angle triangle over here, this one, it fits in nicely because this L is 1, this is y, and this is x. So if you go by that kind of trigonometry, x by L is cos theta. And here L is unity. So that reduces to this formula. In this one. Similarly, y by L is sine theta. And again, L is unity. So this second formula relates to this. And then tan is just ratio of the two. So we don't need to worry about that. Similarly, cosec, cot, etc. will just be defined in terms of inverse. So I'm not getting into those. We don't need those in physics so much. You will be learning about them in maths very soon. Okay, but actually their definition comes from here. Cosec is 1 by sine, sec is 1 upon cos, and cot is 1 by tan. So we don't need to do anything else. So these become our new definitions of sine theta, cos theta, tan theta in terms of what? In terms of a projections of a standard rod. Okay. So a standard rod has unit length in a system of units. Okay, so now let us look at this situation in second quadrant. Okay, so this first I'm minimizing this for you to understand this fully. So this is the definition of sine, cos, tan, but in terms of this, in terms of projection. Okay, so next up, let us look at the situation in second quadrant, how it looks. Okay. So we have a situation in quadrant 2. And this is what is our aim for today, to understand sine, cos, tan in second quadrant. Okay. Later we'll also understand in third and fourth quadrant. But our aim today is how to calculate sine, cos, tan for obtuse angles. So that we can also substitute in triangle law the value of theta as something obtuse. Okay. So if something is in second quadrant, looks something like this, let's say. This is theta. And this is okay. Now when you drop the perpendicular, you can see by definition what is happening. My x is a negative quantity. So this x projection is negative. Whereas this y projection is positive. Okay. Now recall your definitions. What was your cos theta? It was x. So that is becoming negative. So that's why in second quadrant cos is negative. What was your sine theta? it was y, but that is positive. So that's why in second quadrant, ASTC, S, the sign is positive, and tan theta was y by x. So it's the ratio of a positive and negative quantity. So it's negative. Okay. So that is why in second quadrant, this is what happens. In second quadrant, in terms of algebraic sign, cos and tan are negative, whereas sine is positive. Now the next thing is, given the value of theta, how will I actually find the values? Okay. So first just absorb this information and write this down. Then we'll see how to actually get the values. Values कैसे निकालेंगे? Okay. So to get the values, we use a trick now, wherein if this angle was theta, now we express this angle as alpha, suppose. Okay. So alpha is how much? It is 180 degrees minus theta. Okay. And theta is in second quadrant. So that means alpha is an acute angle. It has to be acute, as you can see in the diagram. Okay. Now next what we do is, as usual, we drop these perpendiculars. So this is x and this is y. Now we understand this right angle triangle, this triangle, and I draw it separately here below. Okay. So for this right angle triangle, what is happening is that the hypotenuse is unity. Okay. This angle is alpha, and just as a side length, this is how much? This is mod of y. Because now I'm just looking in terms of triangle geometry. I'm not looking in terms of xy plane. I've taken it outside the xy plane. So I'm just looking at lengths. So these are side lengths. So I have, for the right angle triangle, I have the definition that mod x upon L is how much? It is cos theta. But that theta is now how much? Cos alpha. And we have mod y upon L is how much? Sin alpha. So this tells me that magnitude of x is how much? It is cosine of alpha, because L is unity. And magnitude of y is how much? It is sine alpha, because L is unity. Okay, so now if you put together this information with the definition which we have seen above, now we'll come to the formula that we use for second quadrant. Many of you would have heard of this formula, that for example cos 120 becomes minus cos 60, whereas sine 120 is sine 60, or cos 135 is minus cos 45, whereas sine of 135 is positive of sine 45, like that. So where do the formula come from? They're coming from this. We are going to discuss that. Okay. So we are getting mod x and mod y from this. Okay. Now go back to your earlier definition. So just take a minute, understand this first. Then I'll come back to my earlier definition. So now see, in the quadrant diagram, you can see x is a negative quantity here, whereas y is a positive quantity here. So if I got mod x is this much, what can I say about x itself? It will be negative of mod x because it's a negative quantity. So it will be minus cos alpha. Whereas if mod y is so much, what can we say about y? It is positive of mod y, because y is a positive quantity. So it is positive of sine alpha. Okay, so now we come to the point where, using this trigonometry of the right angle triangle, I've got the x projection and I've got the y projection. The x projection is negative of something, the y projection is positive of something. Okay, so now all I have to do is correlate it with the definition. What is the definition? X is nothing but cos theta. Y is nothing but sine theta. This is the definition. As per the definition in terms of projection. So substitute that definition over here. So what this becomes is that next step. It gives us this formula that X, which is cos theta, by definition is, according to our calculation, it is minus cos alpha, and Y, which is by definition sine theta, is positive of sine alpha. Okay. Which further means that I can break this up and write it like this, that cos theta is negative of cos 180 minus theta, because remember what was alpha? Alpha was that only, 180 minus theta. Whereas sine theta is positive of sine 180 minus theta. And tan theta I can just get from the ratio of this. So tan is the ratio of sine by cos, so it will become minus of tan 180 minus theta. So these just become a simple formula set that we can use for any angle in the second quadrant. So this becomes formula for second quadrant, or theta being greater than 90 but less than equal to 180. Okay. So I'll just leave you with a moment with this, and then we'll wind up today's lecture. So this thing that X is equal to cos theta and Y is equal to sine theta, that is the new definition of sine and cos. That they are defined in terms of projections of a standard length, that length being 1 unit. Yeah. And once we become a little familiar with this formula, you can see we can use it very fast to find out the values. So hope the formula are clear, people. Okay. Now don't worry about the other quadrants right now, third and fourth. Okay, just concentrate on the second quadrant. We'll come to third and fourth also. But for the moment, we need only for obtuse angles. You can also write it as 90 plus something, but I prefer 180 minus because the formulae are easier. If you write it as 90 plus beta or something like that, your cos will become sine and sine will become cos. So I don't want to confuse you with a lot of different formulae like this. So it is. Yeah, so guys, I'll just leave you another 2 minutes. I know the time is well past 2 o'clock, but so for example, now I want to calculate cos of 150 degrees. How do I do this? Or I want to calculate tan of 135 degrees. So how I do that? So I understand in quadrant 2, I relate theta with 180 minus theta. Always. Just remember this. This is the thing that we use. Okay. I relate theta with 180 minus theta and that formula. So cos theta is minus cos 180 minus theta. So here cos 150 will become minus cos 30. So it will become negative of root 3 by 2. Okay. Similarly, if I wanted to calculate sine theta, which I have not asked you, but suppose I want to. So that is positive of sine (180 minus theta). So for example, sine of 150 will become positive of sine 30. And similarly, the formula for tan is that tan theta is minus of tan 180 degrees minus theta. Okay. So here, for example, tan of 135 degrees, 180 minus 135 is 45. It becomes minus of tan 45 degrees, which is minus 1 by. So this is how I will calculate any arbitrary values like this. Okay. So this is where I wanted to conclude today's lecture, people. So we are done. So now you can see that you can start incorporating obtuse angles into the formula of your triangle law. So wherever we have a situation where the vectors A and B's magnitude is known and the angle between them becomes an obtuse angle. So when you need cos theta and sin theta in the formula, you can use these formulae for the obtuse angles. Okay. So like we have discussed these formulae today, we will also be discussing formulae for the third and fourth quadrant later. Okay. Oh, sorry, tan 45 is 1. That's correct. Okay. So just making that correction. It's going to be minus 1. Correct. Yeah. So thanks for the correction. So so this is how we use the values. Okay. So like that, third and fourth quadrant we'll be discussing next time, and next time we'll be discussing something called component algebra of vectors. So if you want, you can start reading ahead about that. But I will be giving you another worksheet which is more applications of this triangle law and more applications of triangle law using obtuse angles. Okay. So you will have to be mindful of these formulae and how to apply them. Okay. So that's it for today's lecture, people. And until next lecture, wish you all the best and stay safe and take all the precautions necessary. It's very important time for all of us. Bye. And if you have any doubts individually, you can message me anytime on WhatsApp. I'll get back to you. Okay. So please complete any questions pending from worksheet 1 and discuss those doubts with me, and you'll be getting worksheet 2 very soon by end of today.